Got the bread. The bread was acquired. We popped off. What do you think? How many rating points do you think I got, Chris? How many rating points do you think? Give me a guess. Give me a guess. 20? Even higher. We got 54. So we got a 2,300 rate. And got the solution to Q4 in like 8 minutes. Then got the commutation to Q3 in 42 minutes. So there we go with that. Okay. So I'm going to go over this question and then that's it. So for this problem, we have minimum deletions to make a k string special. So you're given a string word, enter your k. We consider word to be k special if the frequency of word at I and then from word at j, like the absolute values of it, is less than k. And we want to make sure that every single character basically is less than k. And we want to know how many like things we have to delete in order to get that. So these values can really only go down. And right, so like this problem, okay, of course we're gonna need like a frequency map, like that's one observation. So we need a frequency map. So we need to say like, okay, well, A is like, in this case, I think A was 2 or 4. Okay, A is 4. I think B is 2. And then C is 1, right? So cool, now that we have this, we have like the frequency map. There's the other observation that this is way smaller, right? Like when we have a frequency map, like the constraints of this are 10 to the 5th, but which means an ON squared solution will not work. But we just shorten this down like super large. Like this max this is gonna be is like Z, I think, right? Like Z. So this is like 26, which means we can actually do an O of n squared, right? We can use like a nested for loop and calculate the answer. So second observation is that what we can do is we can kind of go through and try every combo, and we can actually sort this. So we can do 1, 2, 4, and what we can do is we can calculate all of these. We can basically calculate and try to peg all of these down in within the k range of this. So we're kind of anchoring these, right? So like 1 and 2, let's say in this case, right, k is 0. 1 and 2, they need to be 0. Okay, cool. Let's delete it. Okay, what's this one? Oh, you're way too far from 1. Okay, let's peg it. Right, at every step we're just pegging it, and then we'll do the same thing for this one, right? So like let's say we just delete this one, we'll add like we'll have a sum count that says, oh, we deleted you, and now we're only going to do this. And then this one's going to be, okay, let's peg 4, like, you know, everything that's in the future, we're going to kind of anchor it to the 2 within the k bounds. And now there you go, we have 2, right? And so like this one would be, we deleted 2 times, but we also deleted the 1 in the past. So we keep 1 is that when we're doing this algorithm, right, we're going to sort this list so that we can get it in like the shortest length. And so that we're always deleting from like the smallest one first. And then what we're going to do is we're just going to trail through and just keep going. And after, we're going to calculate the total deletions we needed. Here we need 1. Here we need 3 deletions, right? So for a total of 4, we're going to have our final answer be 4. And then we're going to check the same thing for 2. We're going to update our sum with a 1. And then we're going to go through once again 2 and 4. And we do the same thing for this one. So like, okay, here, so like we're like, okay, 2. And then the final answer for this one's going to be 2 plus 1 because we deleted a 1, deleted the 1, and then we were anchoring the 2, and we did that for twice. And then once we do that, we're going to go through here again, delete this one, that's going to give us 3 deleted ones that we tried. And at this case, we're kind of like trying every single combination. And yeah. Okay, so going into the code, we have, we'll create a counter and sort the values so that we can always delete the smallest ones. We will create initialize our variable. So the sum, we're going to start with I, then we're going to start our while loop through, grab the number, count the number of deleted ones we're getting, and then start looping through again This time anchoring every single, value that is out of the range of the number and the k. So we'll check. If the absolute value is greater than k, grit the difference, and then add the difference to the number of deletions that we're going to need to make. And then we're going to add our sum, our running sum, and then we'll increment it, deletions and the running sum. We want to minimize the value, and we just return the answer. You can submit it. There we go. Cool.